lesson we'll be looking at the second part of our lesson, which is vectors 2. And then we have some other subtopics here. The first thing we'll be looking at here is addition and subtraction of vectors. So when we talk about addition and subtraction of vectors, talking about how to add and subtract vector in geometric form. So let's consider geometric form, okay? So geometry has to do with shapes. So here we have vector A, B, and C and the resultant. If you look at the direction, so A goes this way, B goes this way, and C goes this way, and then we have a D. So you see the direction here, and then see the direction of this one. So vector, if you add vector A plus B together, the result will be C. Okay, C is also called the resultant vector, resultant of vector A and B. Okay, so that's the resultant of A and B. This is how to compute resultant of a vector, and it is called vector addition. Okay, so this is vector addition. So you follow the direction. When the direction follows each other, you add. But when the direction goes in the opposite direction, we're going to subtract. So if we have add sorry, AB plus, sorry, let me kind of write it very well because we have two-dimensional. So this is AB plus BC, okay, equals to AC. So let's go that way. Remember how we are taking a vector. Remember, direction goes from A to B, so that is AB. The second direction goes from B to C, that is BC. And then the resultant, see the arrow goes to, the arrow started from A and goes towards C, that is AC. So therefore, AB plus BC equals to AC. Okay, you can see that the one we are adding have 1 point in common. We have point B in common. So also we can add the other one here. We can say that AD plus DC equals to AC. Okay? If we go in the other direction, so AD plus DC equals to AC as well. Okay, so that is addition of vector. Okay, so when we talk about subtraction of vector, okay, so we're still talking about addition. So if you see the this vector, the starting point is A. Starting point is A. Okay, so this is the starting point. So if we add this vector, go in the direction, we have AB plus BC plus CD, okay, plus DE plus EF, and that is, so everything will be equals to AF. Remember, it is not FA. You have to come to the back of the arrow. Consider the arrow whenever you are moving. So consider the arrow. So the resultant, if you add all the vectors together from A to F, we have AF. Okay, and then there are other ways you can even move within this line. So we can decide to take this resultant, let's say this one. So this is this one. Okay, so if the arrow goes this way, you can take resultant from like from here to here, and take resultant from like from here to here, and so on and so forth. Okay, so this will go this way, and this will go this way. So there are many resultant that we can find here. So here, if we follow this one, we can have that A AB plus BF, okay, equals to AF, okay, and BC, okay, plus CD equal to what? BD. You can see the breaking down, and the DE plus EF equals to DF. Okay, So also even inside the bracket, if we take BD plus DF, okay, we're going to get BF. So can you see how it goes? So this is how you can manipulate additional factors. So just follow the arrows. Follow the arrows. So factor subtraction is also very important, okay? And it is done when you have a opposite direction. So it is taken when you have opposite direction, okay? Opposite direction, that is subtraction. So for the factor triangle, AB equals to, you know that AB is OA. The direction is different. You can see that the direction of B, this is the direction of B, and this is the direction of A. The direction does not follow each other. So AB is OA, AO plus OB. Okay. Normally, if we want to add this vector, this is what we are. Let's see the analysis. Remember that vector AB is normally B, vector B minus vector A, right? So if we put the position, that would be OB minus OA. Okay. So if we interchange it, what are we going to add? This is basically displacement. This is when you are computing displacement. Now let's see the addition. Let's see what we are saying. So if you have this and this and this, for instance, so and this is, let's say A, let's say A B C, or we put O somewhere. Let's put O somewhere. So let's say this is O A B. If you look at the direction, OB is opposite, so OB is equals to minus BO, okay, and then we have OA. So therefore, we can have that. I don't think you are going to understand this, but let's just follow the arrow. So where does the arrow follows each other? From OA. So let's say we have OA plus AB, OA plus AB equals to OB. Okay. If we make AB the subject, let's make AB the subject. So that will be AB equal to, you know, OB minus OA. OB minus OA, and this is called vector subtraction. So therefore, you can see we still have what I'm trying to explain there. AB equals to OB, AB equals to OB minus OA. So this is called vector subtraction, and this is the parameter we are trying to explain here, that AB equals to AO plus OB, which is minus A. AO is minus A plus B, okay, which can also be B minus A, okay. So AB equals to B minus A, where AB are position vector of AB respectively, okay. So that is, and it actually follows. It follows from displacement vector, okay. It follows from displacement vector. So displacement vector is an example of vector subtraction. So here are three vectors, R, S, T. Find as a single column vector R plus S plus T. So let's write it down and then start taking it one after the other. So we have vector R equals to 3, 1, 2. Vector S equals to 2, 0, what? 2, 0, 3. Vector T equal to minus 1, minus 2, minus 1, minus 2, 0. Okay, and then for A we have R plus S plus T. So that is going to be equals to 3, 1, 2 plus 2, 0, 3 plus minus 1 minus 2, 0. And that is basically going to be 3 plus 2 minus 1, 1 plus 0 minus 2, 2, 2 plus 3 plus 0. Okay, and that is equal to 4, okay, minus 1, 5. And that is what we have. B. 2r plus 3x. 2r plus 3s. That is going to be 2 bracket 3, 1, 2 plus 3 bracket 2, 0, 3. And that is going to be 6, 2, 4 plus 6, 0, 9. And that is 12, 2, 13. Okay. The next one, s minus t. So